Okay, so today we are continuing the tutorial for double integral. Double integral including for finding the area, volume, surface area using Cartesian coordinate and double coordinates. Let's stop at question 2. So now we continue the question 3. Into a new So some questions the graph is not given, so you have to sketch your own. That's why in the assignment, ask you to plot all kind of graph. Because you need all 2D or 3D graph in this chapter and the last chapter. And make sure your base in this chapter, multiple integration is strong, because we use it again in the vector calculus. Vector calculus is the last chapter where you combine the vector concept that we learned in chapter 3, vector, and the calculus. There is a multiple integration you learned in chapter 2. So each chapter they are actually related. They are not strong in the chapter 2 here. When you go to chapter 4, vector calculus is even more even confused. Also here, if you cannot do your double, triple integral, you don't know how to set up the correct limit, and to set up the correct limit, you must know how to sketch the 2D and 3D graph. So that's why your basic in chapter 1, function of several variables, make sure you know how to sketch the 3D graph and the 2D graph. If not, if you cannot imagine the graph, you cannot set up the correct limit, and it's not stopped in this chapter, we'll drag it to the last chapter, vector calculus. So this one, you have to sketch, they give you the vertices 0, 0, 0, 2, and 2, 2. So you sketch this triangular region so that you can get the equations. This is the xy axis. So the point 0, 0. Say this point is, this is 0, 0. This is 0, 2. So you have 2, 2. If x is 2, y is 2. Say this point is 2, 2. This point. So you want to evaluate, next slide please. Don't late now. Each time I close the E plus and then we will do.
Sorry, Doctor.
Then keep the back package up to big 6 to change the attitude.
Okay, alright.
Then here, this one, we don't know what's the meaning here, we just evaluate this double integral where the integral here is 2xy plus y squared dA. dA over region R. Region R is bounded by these 3 vertices, and it's a triangular region. So this is our region R. This is our region R. So let's say it's easy. I use a vertical bar to sum this region R. So if you use vertical bar, means this look like you form a vertical arrow, and then means if you use a vertical bar, it's actually you evaluate your double integral using dy dx. You use dy dx, so xy plus y squared. I do dy dx. If you don't like, you can change to dx dy. So dy dx, then you must have y. Okay, limit of y, lower limit of y up to upper limit of y. Lower limit of y is actually, okay, when you form your vertical bar, okay, the bottom of the vertical bar touch the x-axis, which is y equal to 0. Okay, vertical bar, okay, touch, okay, bottom at the x-axis, which is y0 up to this case slanting, okay, line, which is actually, yeah, okay, this case linear graph. So how to get this equation for this linear graph? You can see here when, okay, 0, 0, 2, 2. So this equation is actually y equal to x. Y equal to x. Because, okay, x, y are seen, and the, okay, and the slope is actually, okay, if you take the coordinate of, the vertical length is 2, horizontal length is 2, and passes, okay, at the origin. So this is a linear graph y equal to x. That's why the upper limit of y is y up to x. So limit of y is from 0 up to x. Okay. After, okay, when you do this one, it's actually the inner integral here represent the area of one vertical bar. So if you want to get the triangle, okay, this triangular, okay, area, you have to sum the vertical bar. Okay, you want to sum the vertical bar, okay, from left up to right. Okay, left starting x equal to 0 up to right x equal to 2. There's an x from 0 up to 2. That's how we set up the limit for double integral. Is this one using dy dx. Okay, if you can go back to try using dx dy. If you use dx dy, okay, I put up here, but you go to evaluate yourself. Okay, if you want to use dx dy, so the integrand here is same, 2xy plus y squared. This is dx dy. Okay, if you want dx dy, then you will do this. Then you have to find this. When you integrate respect to dx first, it's actually you find area of one horizontal bar. Okay, and then your horizontal bar enter at x equal to 1. So the lower limit here is x equal to 1. Okay, up to here, this vertical line is actually 2. Sorry, this one I labeled wrongly. Should be x 2, y 0, not 0, 2. This coordinate x is 2, y is 0. So here, the vertical line is actually up to x equal to 2. And so if you use dx dy, it's actually we said the lower limit is your left curve. Make x as a title. So x equal y. So the lower limit is y up to 2. Left curve, which is x equal to y. Right curve here is actually x equal to 2. So this is what, okay, the inner integral. Inner integral here is actually you find the area of one horizontal bar. Okay, after that, we will sum the area of the horizontal bar from the bottom. From the bottom, which is y equal to 0. So y equal to 0 up to the topmost point, which is y equal to 2. So this is the limit for if you use dx dy. Okay, if you use here, if you use dy dx, the limit is 0 to x, and this is dy. Okay, dx 0 to 2, dx dy you see y to 2. So you can see in this case, okay, it's not like you changing variable. Okay, if you change variable, it's normally you have a circle area. easy. If dy dx, you form vertical bar, and then the bottom of vertical bar will be a lower limit, top of the vertical bar is your upper limit. Okay, let's sum the vertical bar from left to right. So left point is a lower limit of your x, right point is a upper limit of your x. If dx dy, okay, finds area using horizontal bar, okay, and then lower limit is your left side of your horizontal bar of the left curve, upper limit, okay, for your dx is a right curve. And then you sum the horizontal bar from bottom to top, so which is y0 up to y equal to 2. So okay, dx dy you can evaluate it yourself. So I'm going to just solve this one because both ways will give you the same answer. So when you integrate respect to y, x is constant. So you integrate 2xy where 2y is constant. So you have actually, this one you get x squared y. Because you have x squared divided by 2 and cancel with the 2 here. So you left, okay, x squared y plus integrate y squared the constant. So integrate constant respect to y. Oh, sorry. Do you realize I made a mistake? Because when you integrate respect to y, x constant. So this is wrong. This is integrate respect to x, not y. So this one is not. So that's why when you do the double or triple integral, identify which one is constant first. Okay, this one integrate respect to y. Constant is actually 2x is constant. That's why you should get 2x slowly y squared over 2. And then 2 and 2 here cancel. Okay. Integrate y squared, so y cubed over 3. The limit of y from 0 up to x. X. So you integrate respect to y, please put in y. I don't put in x. You put in x, you say got the y there, then you couldn't integrate lastly respect to x. So total, okay, plug in here x squared times x. So total is x cubed. So you plug in x in variable y here, so it's plus x cubed over 3. Okay, when you minus, when you substitute 0, everything 0. Okay, so lastly, you just integrate respect to x. Okay, just integrate respect to x. So you can use your calculator to integrate directly, or you may use or you may integrate manually. So integrate x cubed, you have x power 4 divided by 4, okay, plus x cubed, so x power 4, so 4 times 3, 12. So put out your limit from 0 to 2. So you got 2 power 4, 16 divided by 4. See, I should just get you can actually you can sum these two first, okay. Add up together, this one we have 4. Okay, now integrate respect to x. So you have 4 over 3. So x power 4 divided by 4. After you integrate, no more integration symbol. This way. Factor out 4 over 3, integrate x cube x power 4 over 4. It limit from 0 to 2. So when you want to evaluate K, simplify first. 1/3. So this one is 2 power 4, 16. So the answer is 16/3. Okay, any questions? No. If no, you can try to double check using dx dy. You should get the same. You should get the same answer. Then we proceed to question number 4. (16/3). Okay, question 4. Okay, the graph is given, then it will be easier because you no need. Because the graph is not given, you may sketch the wrong graph and later on you lead so you get the wrong limit. So if the graph is given, then it will be easier. So you want to find the shaded area bounded by the graph here, x equal y squared. So this is the x equal y squared. So your parabola is actually open at the right hand side. If you have y equal to x squared, then your parabola open up to the positive y axis left right. And if you have y equal x squared, your parabola open up this one. This is x equal y squared. And then y equal to 2 minus x is linear graph. So the y equal to 2 minus x intercept y-intercept at x y equal to 2. Okay, this is a negative slope. Okay, negative slope. Okay. Then to get your x-intercept, you may let y 0 to y 0. So you have 0 equal to 2 minus x. So x equal to 2. So you get 2 here. So with 2 points, you connect it, you get this straight line given by y equal to 2 minus x. Now you want to find the area of this blue color here. So in this case, okay, can you see this region? Okay, do you want to use dy dx or dx dy? Which one easier? So use dx dy or dy dx? Dx dy, correct. Because it bounded by this one, left curve, which is x equal y squared. Okay, right curve, which is y equal to 2 minus x, or you make it become x. Make x as tighter. If you use dx dy, make x as tighter. So you have actually x equal. Let's move to the other side. So x equal 2 minus y. So your x is actually equal to 2 minus y. If you use dy dx, you have to break it into 2 regions. If you want to use dx dy dx, you have to break 2 regions. Region 1, region 2. Because if you use dy dx, okay, region 1, this is your top curve, this is your bottom curve. Region 2, this is your bottom curve, this is your top curve. Because if you use dy dx, you have to do 2 times of your double integral, because their limit up this point is x equal to 1. X equal to 1 will break your region into region 1 and region 2. Because in region 1, your top curve is actually from x equal y squared. Okay, if you want to use dy dx, if you want to use dy dx, then y, you have to make y as either y equal to positive, negative x. So the top curve will be, okay, top here is actually y equal to square root x. Okay, y equal to square root x. Bottom curve is actually y equal to negative square root x. In region 1, okay, your lower limit of y is here, upper limit of y is here, limit of x from 0 to 1. Region 2, okay, your lower limit still y equal to negative sub x, but upper limit become y equal to 2 minus x. And then limit of x is from 1 up to plus 1 up to this point, which is 4. To get this point is actually you have to, okay, this graph is given, you can easily read it. If you sketch your own, then you want to know what's the 4 here, you have to solve this equation simultaneously, then you get x equal to 4. So the easier case for this equation, they use dx dy. Integrate using dx dy, then you have only one region. The whole continuous region where left curve is always x equal y squared, right curve is always x equal to 2 minus 1. Okay, we pick the easier one. Okay. Can you get what I'm talking just now? Okay, I can put up here both limit for you to see. Okay. I put out here, first of all, for dy dx, so that you understand, but you go to integrate yourself. You want to find area. Okay. Okay, first of all, I put the here for dy dx, you have two separate regions. This one dy dx. Region 1, okay, your limit of y is from negative sub x up to positive sub x. Okay, limit of x from 0 to 1. Okay, region 2, limit of x is 1 up to 4. 1 up to 4. Okay, lower limit is actually still negative sub x, but upper limit is actually 2 minus x, dy dx. Okay, this is for if you use dy dx. Because I afraid sometimes I thought you don't know what I'm talking, that's why I write. But you go to evaluate it yourself. Okay. I'm just showing you using the dx dy. Okay. If you use dx dy, limit for your x is actually your left curve. Left curve. X equal y squared. Limit of x. So x equal y squared. Up to x equal 2 minus y. This is 2 minus 1. Okay, from left curve up to right curve. And inside this region is always consistent. Left curve is always x equal y squared up to x equal 2 minus 1. And then if you use dx dy, is actually you sum it using horizontal bar. Horizontal bar. Okay, and it's always consistent. Your horizontal bar is from the minimum point, which is y equal negative 2 up to y equal 1. So limit of y will be negative 2 to 1. Negative 2 up to 1. And then you just evaluate. Then as a practice, you can go back to evaluate this one. And the answer must be same with the x to 1. Integrate it. So integrate 1 dx, you have x, limit is from y squared up to 2 minus y. So this is dy. Plug in, you have 2 minus y squared plus upper limit deduct the substitution of lower limit and integrate respect to y. Okay. Here, if you want faster, maybe you just use calculator. Use calculator. And you can solve more questions. Okay, you can practice manually. Okay. The outer you can always use your calculator. Of course, why the calculator is you have to change it to x. So 2 minus x minus limit from negative 2 up to 1. The answer is 9/2. So any questions here? Or question number 4? Question number 4 here. Any question?
No.
If no, you can just practice your your skill of integration. You can try to do this one, and the answer must be 9/2. Okay, question 5. Sketch the region R. So this will be tougher question because you have to sketch your own region R. So if you are weak in sketching the graph, then you will put up the wrong limit. Sketch the region R, which is enclosed by the curve y equal to x squared and y equal sub x. This is y equal x squared. Y equals sub x exactly. Here, only upper part. I mean the green color only. Okay, the red color here is actually y equal negative sub x. I mean the whole complete parabola is x equal y squared. If you cut it horizontally at x-axis, this green color graph is actually y equal sub x. So you combine this graph and this green color. Okay, set up the double integral to find the area of the region R. Evaluate the area. So for A here, this. So you have, yeah, this is a parabola. This is y. This one is y equal x squared. And y equal sub x. Okay. So you want to know what is the point here. What is the intersection point? Then you have to solve these two equations simultaneously. So okay, this is y, that's why they are equal. X squared equal sub x. Okay, when you square it, to eliminate this one, if you square both hand side, this will be x power 4 equal x. Now, one intersection point is x0 or x cubed equal 1. Okay, x cubed equal 1 provided at where? X is 1. So this point 0, this point 1. Plug in. So this is a region here. The R is bounded by the blue color and the red color. Blue color is y equal set x. The intersection point is actually x is 1. When x is 1, you plug in here, y is actually 1. So, okay, this sketch, okay, part A, sketch the region R. Okay, after you sketch, make sure you get the intersection point. Or the intersection point, okay, will determine the limit. So this is x, this is the y. So set up the double integral to find area of the region R. So area is actually given by double integral dA over region R. So in this case, which one you want to use? dy dx or dx dy? Which one? Yes. Using dy dx. So you have y as a title, use dy dx to be easier. Okay. So dy dx, lower curve is actually the red color, which is y equal x squared. Upper curve is a blue color, which is y equal set x. So, okay, dy dx. So, x is actually from 0 up to 1. We just evaluate it. Integrate 1 dy is y from x squared up to set x. Then we have so dx lastly we have 0 to 1 set x minus x squared x. Then you use your calculator to put through. Integrate set x minus x squared from 0 up to 1. This is 1/3. This is your question 5. Okay, D set up, the D is here, set out the limit. Okay, this is up to part C, the answer is 1/3. So any questions here? Question 5. Question 5 a bit tougher because you need to sketch your own graph, okay, and determine the intersection point before you set up the limit and evaluate it. Then number 6, okay. Find by using double integral, find the area of region R. Okay, again, so you have to sketch your own region R. By the curve y equal 1 over x squared, y equal to negative x squared, and line x equal to 1 and x equal to 2. Okay, calculate the volume of the solid enclosed. Enclosed by cylinder x squared plus y squared equal to 9. Plane y plus z equal to 4 and z equal to 0. So let's look at the question 6a first. You have to sketch the curve y equal 1 over x squared. Okay, x squared, when you squared, when x negative or positive, you square it always positive. That's why y is always positive. So your region is actually this is x, this is 1. Because y equal 1 over x, the graph is like this. Because when x positive, y positive, x negative, okay, x negative, y get negative. So this y equal 1 over x graph. Okay, but they never touch, okay, y equal to 0. Because 1 divided by okay, x, okay, never touch, okay, x 0, y 0. Because when x approaches 0, 1 divided 0 is actually infinity. That's why it's go up. Like this graph. And then when x is a very big number, 1 divided a very big number, actually will approaches, okay, 0, but never touch 0. So this is a graph of y equal 1 over x. 1 over x squared, because okay, even though x here negative, you square it, you get positive. That's why y is always positive. It's split into here. So this is a graph of y equal 1 over x squared. Okay, and then y equal negative x squared. Okay. This is y equal positive x squared. Your parabola open up because y positive. Okay, if y equal negative, so mean y negative, is why your parabola will flip down. It reflect it down because y now negative. Red color. Red color is actually y equal negative x squared. It bounded by, okay, x equal 1. x1, x2. Let's say this point is 1, this point is 2. So you want to find the region here. So you want to find the region bounded by the curve y equal negative x squared, y equal 1 over x squared, and x bounded by 1 to 2. So in this case, which one, okay, you should use dy dx or dx dy. Which one? Yes, right. You understand, because the curve is bounded by bottom curve y equal negative x squared, upper curve which is y equal 1 over x squared. So this one, okay, we use dy dx. And the area will be y from negative x squared up to 1 over x squared. This is dy dx. Okay, x from 1 up to 2. And we just evaluate it. From negative x squared up to 1 over x squared dx. 1 over x squared minus negative x squared dx. So lastly, okay, you can just use your calculator. Okay, use your calculator to integrate it. Integrate 1 over x squared. So negative, negative, positive. So plus x squared. Integrate x from 1 to 2. The answer, okay, sometimes it can give you fractions, sometimes it give you floating point. So this one you get the fractions 17 over 6. So this is questions 6A. So is it okay? Okay.
Okay.
And then 6B is volume. To find the volume is actually our volume formula. Volume is actually if double integral. The integral is f x y dA over region R. Fxy equal to z. So you see volume, okay, the formula, the integrand is fxy, which is equal to z. If area, the integrand is 1. So okay, make sure you understand the formula. So what is z? Here you got z, right? So z 4 minus 1. So the integrand, you put it 4 minus 1. Calculate the volume of the solid enclosed by cylinder x squared plus y squared equal to 9, plane y plus z equal to 4. Imagine your solid here. Okay. Normally in 2D, x squared plus y squared is circle. In 3D, it becomes cylinder. This is okay. In 2D, this is y, this is the x. Then you have circle with radius 3 unit. This is r equal 3. Negative 3, positive 3, this is negative 3, this is positive 3. This is x squared plus y squared equal 9 or r equal 3. So region R is circular. Later on we use polar coordinate. Okay. For that, we want to imagine in 2D this is circle, in 3D you pull out the cylinder. Like imagine you have a tub, your water tumbler, where when you press it you get a circle. When you pull up, if you have a paper tunnel, you pull up, you get a cylinder. That's why this cylinder x squared plus y squared equal to 9 will be parallel to your z-axis. Okay, and bounded by the plane z equals 0. Okay, this is a cylinder. 3D it becomes cylinder. Later on the cylinder is actually, in 3D cylinder is actually from a negative infinity up to positive infinity. To find the volume, we must bound it. Now the lower surface is bounded by xy plane, which is z0 flat. Imagine your water tumbler flat. Okay, and bottom is at z equal 0. Okay, if your water tumbler, of course, top is flat. If flat will be z equal a constant. But here, upper surface of the cylinder, means the cylinder, of course, this is flat. But now, the cylinder is bounded by another plane, y plus z equal 4. Y plus z equal 4. Then, let's say, actually cylinder, we don't know, can open up to the positive infinity, and let's say here, say this one is 4 here. Cut it another plane. This is a plane y plus z equal 4. So y plus z, okay? When z is 0, y is 4. Okay, when y is 0, z is 4. So the plane will be cutting here. So the resultant cylinder will be like here. Okay. That's also cylinder. So the resultant will be like here. This is cylinder. Resultant will be like this one. Cylinder, okay, bounded by z0 and actually upper part, okay, or up to cos infinity, cut by the plane y plus z equal 4. So resultant will be like here. So we want to find the volume of this, the resultant solid here. So it's in a 4, 4 and cut it, so the resultant will be like this. And then he knows that volume is double integral f xy dA over region R. fxy is z. Z, okay, from here, z is 4 minus 1. So you have 4 minus 1. Okay, dA. The region R is circular region. Region R. Put it in 2D. Region R is circular. So we use polar coordinate. dA change to R, dr, theta. Put it here. Because this is actually x squared plus y squared equal 9 or r equal 3. So okay, in circular region, we use polar coordinate. Then polar coordinate y is r sin theta. dA is r dr theta. Limit of r is actually, to get the limit of r from here, origin up to here, which is 0 up to 3. So limit of r 0 up to 3. Okay, theta. Okay, theta is actually we rotate from x positive. We rotate it this way. So a full cycle, theta from 0 to 2 pi. So lastly, we get the double integral, evaluate it in the 0 to 2 pi. Integrate, before you integrate, I think you have to simplify first because multiply by r outside. We got 0 to 3. So this is 4r minus r squared sin theta. 4r minus r squared sin theta dr d theta. So when you integrate respect to r, theta is constant. So integrate 4r, we have 2r squared. So integrate r squared, sin theta is constant, so you get negative r cubed over 3 sin theta. Limit of r is from 0 to 3. Then you put in the limit. So plug in k into r. Plug into r here. So 3 squared k is 9. 9 times 2 is 18. So 3 cubed is 27 divided by 3. So we have 9 sin theta. Plug in 0, everything 0. Then lastly, you integrate respect to theta. Okay. So this one we have 18 theta minus 9. Integrate sin. We have integrate sin is negative cos. So that's why integrate plus cos theta 0 to 2 pi. Integrate negative sin theta, you get positive cos theta plus c. So that's why you get plus 9 cos theta 0 to 2 pi. So plug in the upper limit of 18 times 2 pi plus 9 cos 2 pi, then minus when theta plug in with 0, we have 0, 9 cos 0. The answer is 36 pi. Cos 2 pi is actually 1, and then cos 0 is actually 1. So positive 9 minus 9, that's why the answer is 36 pi. Answer is 36 pi. So any question for this one? Question 6b. Any questions? Yeah, I'm not sure whether you are listening or not. No question or not listen. No question. So make sure when tests are also no question. Everything answered perfectly 100%. Question 7 again. Depict the area. Draw the area bounded by the curve x equal 1 minus 1, y minus 1 squared, and y equal 3, and y axis. Using examine the area in question 7 using dx dy dy dx. Back to area. So just now you have since the curve x equal y squared, right? This one. This is x equal y squared. So now if you want x equal y minus 1 squared, what happens if you want x equal y minus 1 squared? This is a curve x equal y squared. So if y is actually minus 1, means is y x. So y will be shifted up 1 unit. We move up. Because y, y now y minus 1. So in the technique of sketching graph, when y is minus 1 means actually coordinate of y will be shift up 1 unit. So still the same parabola, but now it's moved up. So the minimum point, this vertex would keep at y equal to 1. Okay, so you sketch it the curve. It's a parabola. Now this point is 1. Okay, this point 1, and then so how the open. So this is a x equal y minus 1 squared. Okay, y equal 3. Say this one here. Let's say y equal 3. This is 3. Y-axis. So this is a y-axis is here. So you want to find the area bounded by the curve. This one. X equal y minus 1 squared, y equal 3, y-axis. So the region is here. Isograph. Let's draw using the metal one. This is good. This one is freehand. This is using the metal. So you see the vertex at the parabola. Initially here, if you have x equal y squared, your parabola point is here. Now move up to y equal 1. And then bounded by y equal 3. Bounded by y-axis. So it's this region. The blue color region, area that they the question 1 to 5. So know the correct region. So using dx dy technique, and then the d using dy dx. Let's say A, you want to use dx dy, dx dy. So left curve here. Y-axis is x equal 0. Right curve here. Okay, right curve. This one is what? X equal y minus 1 squared. And then, lower limit of the y is 1 up to 3. So the area is actually y from 1 to 3, x from 0 up to y minus 1 squared. This is dx dy. And then you just integrate it. So you have x and 0 up to y minus 1 squared y. Y minus 1 squared minus plug in 0 is 0. Stay 1. So same thing here. You can use just use your calculator. Of course, y you have to change to x, y minus 1 squared from 1 up to 3. So the answer is 8 over 3. This is using dx dy. Okay, if one dy dx, if using dy dx, the bottom curve is actually here. This one is x equal y minus 1 squared. If you want to use dy dx, the lower curve is here, upper curve is actually this one, y equal 3. If you use dy dx, lower curve x equal y minus 1 squared. If you use dy dx, you have to make y as a title. That's why from x equal y minus 1 squared, you have to make y as a title. You must have y equal function of x. So to get the y as a title, squared, I have to take square root. So this will be, if I taking square root both hand side, so you have a square root x equal to y minus 1. Okay. Therefore, y is equal to sub x plus 1. So the lower limit of y will be y equals sub x plus 1. Upper limit is y equal to 3. And then you sum the vertical bar from y-axis, which is x0 up to, okay, so what is this point? Okay, because this is given by the, okay, sketching by mapper, you can see is 4, but if you, okay, do it manually, okay, if you sketch manually like here, if you sketch manually, then you know, okay, you have to determine what is this value, okay, what is this value, okay, to determine what is the intersection point of y equal 3 and x equal to y minus 1 squared, you solve these two equations simultaneously. You have x equal y minus 1 squared, okay, and this is y equal 3. So another one is y equal 3. So you plug in y equal 3 to x equal y minus 1 squared. So you have x equal 3 minus 1, you have what? Okay, 2 squared is 4. That's why here it's actually x equal 4. So first, if you want to do using dy dx, okay, x from 0 up to 4, okay, y from, okay, this is a lower curve, which is sub x plus 1 up to y equal 3, dy dx. Okay, lower curve. This one, they give you x as a title, change it to y. Then, okay, the top curve is y equal 3. Sum the vertical bar from left, which is y-axis, x0, up to here, the intersection point, which is x equal 4. So actually, this question easier we use dx dy. But since the question 1, dy dx 2, that's why you have to do it. 0 to 4. Integrate 1 respect to y, you have y. So product limit is from sub x plus 1 up to 3, and then x. So you have 3 minus sub x plus 1 dx. So you have 8, actually, integrate 0 to 4, okay, simplify it. Open up, okay, so 3 minus 1 is 2, so 2 minus sub x dx. Get the answer quickly. I just use calculator. 2 minus sub x. 0 to 4. If you keep 2.67. So okay, sometimes it can give you the fraction nicely, sometimes they give in the floating point. So this is question 6. Question 7. So any questions? Out of that. Okay. And then question 8. Question 8. Sketch the region R which is enclosed by the curve y equal x, x equals 0, 2x plus y equal 6. Y equal x. x equals 0. X equals 0 is a y-axis. This one. 2x plus y equals 6. Okay, first of all, when you let x 0, y is 6. Okay, x 0, y is 6. Let's say that y is 6. Okay. Later on, when you let y 0, okay, when you let y 0, 2x is 6, so x is 3. Let's say that y is 3. Then you connect it. So this will be your 2x plus y equal 6. So where is the region that we want? So the region bounded by y-axis, x0 is actually y-axis. Okay, bounded by y-axis, this one, okay, 2x plus y equals 6 and y equal x. So here, okay, the region will be here. 1, 2, 3, bounded by these three curves, 1, 2, 3. If you choose here, okay, it's wrong because 1, 2, this is actually x-axis is y0. We want x equals 0. So 1, 2, 3 curve. So is it okay? Make sure you sketch the correct region. If you choose this region, then your limit will be wrong later on. Bounded by y equal x, this one, 2x plus y equals 6, x equals 0, y-axis. So 1, 2, 3, 3 curves. So this region. Okay. Part B. Set up the double integral to find the volume of the solid enclosed by the plane 8x plus 4y plus z equal 24. Okay. This is a tetrahedron, okay, and y equal x, z 0, x equal 0. This one is actually in 3D. X, y, z. To sketch it, okay, first of all, let's say you let this to 0. So z is actually 24. This one is 24. So similarly, let's say this to 0. So 4y is 24. So y is 6. 6 left. To get the x intercept, let y z 0. So 8x is 24, x will be 3. See, actually, and then you connect it. So this is a plane 8x plus 4y plus z equal 24. In the first octant, where x positive, z positive, okay, and bounded by y equal x is here. So to use double integral, when you want to find the volume of this tetrahedron bounded by z0, x0, x0 actually your x-axis, and then the y equal to x. Okay, you could sketch y equal to x here. And then, okay, this is in 2D. In 3D, actually to sketch something I think that we do. Something is very difficult to do. Okay, the resultant is very difficult to do, but you know volume is actually using double integral. Volume is double integral your f x y A over region R. This is a region R here. Okay, the region R actually here. So mean is actually not the whole volume, okay, bounded by this one part, but is what the sketch C. Okay, the volume, okay, the projection is here, okay, and then what you want to evaluate it, we know fxy is actually z. fxy is z. So from here you make z as a title. Okay, when you make from here when you make z as a title, you have z actually equal to 24 minus 8x minus 4y. Okay. Put it here. 24 minus 8x minus 4y. Okay, dA. dA here, this is a region in dA is actually on 2D, 2D, yeah, xy plane. This region, let's say I use dy dx. dy dx, we sum using vertical bar. So lower limit of y is actually the lower curve, which is y equal x. So y equal x. Okay, up to the upper curve. Okay, you have to make y as a title, which is y equal 6 minus 2x. So y equal 6 minus 2x. Okay, x is actually from 0. Okay, and then you have to put 3. Yeah. So it's up to here, this intersection point. So x from 0 up to. So what's x here? You have to solve these two equations simultaneously. Solve y equal, you have to solve, okay, 2x plus y equals 6, okay, and y equal x simultaneously in order to get this intersection point or the upper limit of the x. So you plug in here, put it here, so you have 2x plus x equal 6. 3x equals 6, so means x equal 2. That's why x from 0 up to 2. And this point is 2. So, okay, so this is a limit of the price of volume bounded by the plane x plus y plus z equal to 4 and y equal to x. But I failed to sketch the resultant volume for you to see. Okay, up to this point, any questions? I just use the volume is double integral fxy a. So fxy is z. So from the here, get up the z, put up here. Later on, you just sketch that 2D, the region bounded by 2x plus y equals 6 and y equal to x, and the x equals 0. So the 2D will help you determine the limit for your y and x. After that, you just evaluate it. Okay, when you integrate respect to y, 24 and x are constant. So I will group together 24 minus 8x is constant. So integrate constant respect to y, you have constant times y. So integrate negative 4y, you get 2y squared. Y squared divided by 2. So 4 divided by 2, you get 2. You put up the limit from x up to 6 minus 2x. And then x is equal to 2. So you integrate respect to y, make sure plug in into y. Plug in into y. Okay, come on. Plug in into y, plug in into y. That's why we have 24 minus 8x times y, which is 6 minus 2x. So minus 2 times your y squared. So 6 minus 2x squared. And then minus minus, okay, plug it into the x here. So minus, you have 24 minus 8x times x minus 2x squared. Integrate respect to x. Okay. You can, I'm not sure whether the computer can key in directly like this. You can have a try, or else you have to simplify. You have to try. I'm not sure whether it can or not. Or else you have to simplify, then and then manually, or get the simplest case, the simplest case form. Then you will use the calculator. Because I'm not sure whether it can or not. Like this. These two can be collected. Minus x. Minus 2x minus x. Add together first, otherwise very long to key in. Here you have 24 minus 8x, 24 minus 8x. This is minus, minus this one. 24 minus 8x. 6 minus 2x. Here, one more x, so total is 6 minus 3x. Here, minus 2x times this one. Okay, here, one more time, minus x times here, so total is minus 3x. Then minus 8 times 6 minus 2x squared minus 2 minus this is positive with x squared. X. So try here whether it can. Otherwise, you have to expand and integrate it manually.
Dapat 112 over 3.
112
Over 3.
2 over 3. The answer is 48. You key in this one. The answer should be 48. 4 minus 8 6 minus 3 minus 8x times 6 minus 3x. So we need from 0 to 2. Okay, correct. So you see here, and I don't know how you key in, but here I'm afraid it couldn't understand. That's why after I put this one bracket, and then I key exactly. You see the yellow color here. I put a bracket, and then 24 minus 8x bracket times bracket 6 minus 3x minus 2 bracket 6 minus 2x squared, okay, plus 2x squared bracket. Okay, I key in exactly. Make sure all your bracket there. Okay, open, close. Because I'm not sure, you can try it without the yellow bracket if you get the answer. This one, okay, I simplify here, this term. This is minus, this is minus x, minus 2x, so total is minus 3x. Because if you expand, normally you have careless mistake, especially okay, when the solid is a tetrahedron, easily get careless mistake. Okay, just now you get the answer, do you check what's the mistake, okay, that you get not the accurate answer. So answer, you will get what the 112 divide what?
48. 48.
Yeah.
I forgot the third one.
Oh, okay. So not correct. So using calculator faster and easy, you can get 48. If not, okay, it's quite tedious. Expand, and then collect back, integrate manually, quite tedious using calculator. But using calculator provided, if you can simplify it, and then make sure you key in correctly. Otherwise, also you get wrong answer. Okay, later I will give the full solution, which is manual. You can check that. So this is question 8, and then question 9. Okay, mass. I think I can teach mass. So, okay, for double integral, you can find area, volume, surface area, one more the mass, and the project you have a lot of, okay, I think moment of Malaysia, center of, okay, center of whatever, all kind of the application. So there is in the project, okay, just okay, you just look at the formula and then know your the surface. Then you just change it accordingly. So this one to find the mass of lamina. We sketch the region first, and then I give you here the mass of lamina. Okay, lamina is actually a thin sheet. This lamina is actually in 2D. So lamina is a very thin sheet. In this case, lamina in 2D. So lamina only consists of area without volume. So your lamina bounded by the curve y equal set x. So this is I'm trying to see this curve. Y equal set x, x equal 9. Let's say this is x equal 9, y equals 0. Yeah. So this is your region R. Because y equals 0 is your x-axis. So you know, okay, you know your region is actually y equal set x, and then x-axis is actually y equal 0 up to x equal to 9. So this is origin, which is x 0. So easy, we use the dy dx technique. Okay, and the mass of the lamina is actually m equal double integral the density, which is delta xy dA over region R. Okay, because lamina is a thin sheet, the lamina in this case is shaded by this region R. Okay, it's very thin, don't have the height, only have the area. Okay, and you learned, okay, last time, I think in secondary school in physics, density last time in physics, we use the symbol rho. Remember, rho is your mass divided by volume. But lamina only consists of area without height. That's why only have area. So we can also say density if without volume is mass divided by area. Okay. So now if you want to find the mass, so mass will be the density times area. Okay, we use this formula provided you have a constant density. But in this case, we have the variable density, which is x plus y. That's why the mass is given by, mass of lamina is given by double integral density, double integral density function delta xy dA over region R. Here we use a delta function because the rho later on will involve as a radius of a sphere in the spherical coordinate in triple integration, triple integral. In next week we are moving to triple integral. We have the dv, which is dz, dy, dx. And we can use polar coordinate in 3D, which is called as cylindrical coordinate or spherical coordinate. So the rho is used in the spherical coordinate. That's why density function here we use a delta. So this is a mass of a lamina in 2 dimensions. Later on we may have a mass of a lamina, mass of a solid in 3D. And in the last chapter, later on we learn line integral, surface integral. You may have a mass of a thin wire. The wire only consists of length without area. So the density also can be your mass divided by the length. So if solid, then the density is mass divided by volume. We got 2D, mass of lamina, so mass divided by area. And then, if you have a wire, the mass density of a wire is mass divided by the length. So now, because the density is not constant, that's why we use a double integral. So you notice, this is a mass of a lamina in 2D. So now, we call back, when we solve, we call back double integral. Initially, you have area of this region R is double integral dA over region R. So dA up to you to, or depend on the shape of region R, can be dy dx, dx dy, or use polar coordinate R, dr, etc. Okay, and volume is actually given by f x y dA over region R. Okay, this volume is actually mean the volume where the top surface is equal to z, bottom surface is on xy plane. And you may have the surface area is actually given by 1 plus zx squared plus zy squared dA over region R. So mean you have just now, what is the surface area? For example, just now, we want to find in the area of this 3D. We want to find the area of this cylinder below the curve z equal to 4 minus 1. So the area of the solid in 3D, that's what we call space area. So this area, this volume, this is surface area, and this is a mass of a lamina in 2 dimensions. And the project, you have all kind of applications there. So it's only the integrand that change. So you have the module, you can see you will have a moment of inertia, center of mass, center of point, all kind of application in the projects there. So now we move back to this question 9. So our integrand is density function, which is x plus y. Here is this function. Use dy dx, so x from 0 to 9, y from x-axis, which is 0, up to the y equal set x. Delta xy is given by x plus y. That dy dx. Now we just integrate it. So when you integrate respect to y, x is constant. So integrate x, we have xy. Integrate y, y squared over 2. Without limit from 0 to set x dx. Then substitute the limit first. So you integrate respect to y. So make sure you plug in into y. So after we have x times sub x. Okay, sub x squared we have x squared over 2. Plug in 0, everything 0. Then here you can simplify it. Okay, x power 1, x squared is actually power half. So total is x power 3 over 2 plus x squared over 2. Okay, and you can just use a scientific calculator to get the answer. This is x. Because sub x squared, so this is only x and not x squared. So integrate x power 3 over 2 plus 8 from 0 to 9. So we get the answer over 7.4 over 7.5. Answer into 0.7.5. If you do manually, this is the answer. 2, 3, 4, 9 divided by 20. So this is using a calculator over 7.45. If you use it manually, you will have 2349 over 20. So any question for the mass of a lamina? M is a double integral, the density function dA over region R. So make sure you can sketch the correct region R. If you sketch wrongly, then will affect your limit of the y and x. Question 10. Again, is mass of the lamina. Please sketch the region R of a lamina, which is bounded by the curve y equal square root 1 minus x squared in the first quadrant. Okay, this equation is actually, when you square it back, you have y squared equal 1 minus x squared. Okay, or x squared plus y squared equal 1. When you square back, this is actually circle. But if y equals square root 1 minus x squared, this is actually upper circular. Okay, upper circle, upper semicircle, sorry. Okay. This is -1, +1. This is 1. This is y equal square root 1 minus x squared. When you square back, you have a full circle. And then from the circle, if you cut at the x-axis, like imagine you have a cake, okay, with radius 1, let's say 1 unit. Here you cut it here, x-axis, so you get a semicircle. So the equation for semicircle is from here. If you cut it at x-axis, you make y as a title. So this is y, okay, upper part is y positive, that's a y equal square root 1 minus x squared. So in the first quadrant, okay, they want first quadrant, so mean it's only this part. So okay, the region R is in the first quadrant, x positive, y positive. Okay, and part B, the density function of the lamina is given by delta xy equal to cos x squared plus y squared. Set up the double integral to find the mass of the lamina in Cartesian coordinate. Okay, we want to set up in Cartesian coordinate. So that would be all that. The mass of lamina is given by a double integral delta xy dA over region R. Okay, the one in Cartesian coordinate, and delta xy is given by cos x squared plus y squared. Okay, and we see this region R is actually bounded by x-axis. X-axis is actually y equal 0. Means the lower curve is y equal to 0. Upper curve is y equal to square root 1 minus x squared. You use vertical bar. Vertical bar enter at y equal 0 up to y equal square root 1 minus x squared. So we use dy dx. So y from 0 up to square root 1 minus x squared. In the first quadrant only, so x from 0 up to 1. So this is answer for question B. And then, okay, by converting the Cartesian coordinate to polar coordinate, find the mass of the lamina in this bounded by this region R. Because as we learned last night, if the region R is bounded by circular region, in here is a quadrant of the circle, it will be easier to use polar coordinate. Because if not use polar coordinate, later on you will meet with the integrand square root 1 minus x squared, where you need to use trigonometric substitution. It will be difficult to integrate. So it will be easier to change it to polar coordinate. So when you change it to polar coordinate, x squared plus y squared is actually r squared. So you have cos r squared. dy dx is actually r dr theta. R you don't group into cos. And then limit of r is actually, to get limit of r, that's why initially the y equals square root 1 minus x squared, I squared back. Okay, I get x squared plus y squared equal 1. Means r squared equal 1, r is 1. Remember, r is magnitude, is always positive number. Okay, to get the r is actually, get r 0 up to 1. So r from origin, this is 0 up to this circle, which is x squared plus y squared equal to 1, r is actually 1. So r from 0 to 1. Okay, and the theta is actually in the first quadrant only. Okay, from positive x-axis, theta equal to 0. Okay, up to the positive y-axis. Okay, here, this is theta equal to pi over 2. Because only here. If we got semicircle, then theta up to pi. If we got full circle, theta up to 2 pi. So in this case, theta is only up to pi over 2. So from 0 up to pi over 2. Okay. So this one, this is cos r squared times r. 0 pi over 2. Exactly, we have r cos r squared, r theta. Okay, and then if you don't know how to integrate, this case is actually you can use your calculator because the limit here is constant. The limit is constant. So okay, of course, r you have to change to x. Here. Cos. Here I don't put bracket, doesn't matter because it's multiplication form. And then I put it this one to your calculator first. 0 to 1. I get this answer 0.4207. Zero to pi over 2. Okay, the inner is 0.4207. So this one is theta 0 to pi over 2. So 0.4207 times pi over 2. So the answer you can time pi divide 2. 0.6609. This is using calculator. This is using calculator. If you use manually, okay, if you use manually to integrate here, if you use manually, so I put up red color, to integrate r cos r squared dr, I will let q equal to r squared. So du is 2r dr. So you notice we got the term active here, r dr. I put front because afraid sum will become cos r cubed. Because I'm afraid sum will group together cos r cubed, which is wrong. You have the cos r squared term multiplied r. So you notice, okay, the term, you have the term r dr where you replace by du over 2. This du over 2 is your r dr. Okay, so your integrations, I didn't put up the limit one. The integration cos r squared r dr, it become r squared replaced by u, so become cos u. R dr is actually du divided by 2, so you have half, okay, cos u du. So integrate cos is sin. Cos is sin u. Cos is sin u. So mean this one zero to pi over 2. Okay. where the u is actually r squared. So r, okay, cos r squared dr, you get its answer is half sin r squared, where r from 0 to 1. Then lastly, integrate respect to theta. Factor out half, integrate 0 to pi over 2. Okay, plug in 1, so you have sin 1. Plug in 0, sin 0 is 0. That's why you have sin 1 d theta. Sin 1 is a constant value, so you have actually sin 1 divided by 2, integrate 0 to pi over 2 to theta. Okay, this part you get pi over 2, so your answer is sin 1 divided by 2 times pi over 2. Okay, this one if you evaluate manually, you want to see whether both give the same answer, then this one you have to change it to floating point. Sin 1, make sure in radian mode, right 2 times 2 pi divided by 2. 2.6609. I'll show you both technique. This one, in case you don't know how to integrate and the limit is constant, then you make use of your calculator. So you get the answer 0.4207. So this is constant, factor out. Lastly, you integrate this one 1 d theta from 0 to pi over 2. You get the answer is pi over 2. So this is the last answer. This is using substitution technique. It replace u equal to r squared. So du is 2r dr. You notice you have r dr, right? So r dr change to du over 2. So cos r squared become cos u. Integrate cos u, you have positive sin u. Replace back the u exactly r squared. So the inner integral, you get the result is half sin r squared. So here, that's why I didn't put limit. Okay, when I integrate respect to u, I didn't put limit, I put indefinite integral. So lastly, this one you get half sin r squared, then you put the r from 0 to 1. And at last, integrate respect to theta. So any question here for question 10 here?
Not at that.
Sit down in the rest. Eleven is also area and not area. From question 11 onward, I think using the polar coordinate and the surface area. Polar coordinate. This is a straightforward question. Evaluate double integral x, y, dA over region R, where R is a region in the first quadrant bounded by x squared plus y squared equal to 4, x squared plus y squared equal to 25. Okay. In first quadrant, so you have here, this is actually R2, this is R5. So this is 2, 2. 1, this is 5, 5. This is a circle with radius 2 units centered at origin. Circle with radius 5 units centered at origin. And because first quadrant, so I just sketch here. And then, okay, since circular bounded by these two, this corner area in the first quadrant. So circular region easier we use polar coordinate. So in this case, to determine the R, sketch here. So R enter at R equal 2 up to R equal 5. So limit of R it will be 2 to 5. So your double integral x, y, dA. For circular region we use polar coordinate. So x is actually R cos theta, y is R sin theta, dA is R dr theta, R from 2 to 5, theta from 0 to pi over 2. So this theta 0 up to y-axis, keep theta equal to pi over 2. Then you rotate here 90 degrees. Then you simplify first. In total R cube. R cube, sorry, this one cos theta, R cube cos theta sin theta dr theta, R from 2 to 5, theta from 0 up to pi over 2. Integrate respect to R, theta is constant. So integrate R cube, you have R power 4 divided by 4. So I factor out constant here. Then 2 to 5. Now this is in multiplication form. This is a constant. So I factor out cos theta, sin theta, theta. Because 1 over 4 times R power 4 times cos theta sin theta theta. So put out the limit for R. So 0 to pi over 2. So you have pi power 4 minus 2 power 4. Okay. And then cos theta sin theta theta. So please evaluate 5 power 4 minus 2 power 4. 5 power 4 minus 2 power 4 is 16. So total 609 over 4. So this one you get 609, so divided by 4. Okay, and then cos theta sin theta. Remember you have sin 2 theta is 2, sin theta cos theta. So that's why cos theta sin theta, I will change it to sin 2 theta divided by 2 theta. Or you want to use your calculator to integrate it, also can. So total is 609 divided by 8. Factor out 2, so 4 times 2, 8. Integrate sin is negative cos 2 theta divided by 2. If you multiply sin, if you differentiate sin, you got 2 positive 2 cos 2 theta. Integrate is negative cos 2 theta divided 2. Then from 0 to pi over 2. So I factor out negative 609. So 8 times 2, 16. And then cos. So replace theta by pi over 2. So minus cos 0. So this is actually cos pi. Cos 0 is 1. Cos pi is negative 1. Cos pi is negative 1 minus 1. Remember, yesterday I sketched for you to see. This is pi, where the value is negative 1. This is a graph of y equal cos x from 0 to 2 pi. Cos pi is negative 1. So total negative 2, negative, negative, positive. So you have 609, 16 to 65, 609 divided by 8. This is when I evaluate manually. So the answer is 609 divided by 8. If you check, if you use calculator up to here, whether your calculator can integrate cos theta, sin theta. See whether we can get the same answer. Outside, put 609 divided by 4. Integrating from here. This form. Here, this value is 609 divided by 4, and then when I didn't change to sin 2 theta divided by 2. Let's say you cannot remember the formula and you don't know how to integrate, then you use your calculator. So this is your cos x sin x, integrate from 0 to divided by 2. So using calculator straight away, you get 609 over 8. Mean from this line, you have actually 609 divided by 4. You straight away integrate cos theta, sin theta, theta. Yeah, cos in calculator, theta you change to x1. 609 integrate this one 0 to pi over 2. 609 over 4, integrate the limit 0 to pi over 2, cos x sin x. The answer is 609 over 8 straight away, even it by the calculator. Okay, thumbs up. Okay. So the rest, okay, please do it. Okay, polar coordinate, and then the surface area. Okay, so any questions before we end the class? Okay, if not, we are going to dismiss. Okay, we'll see you next Monday.